Hey, you ever felt like your local coding setup is speaking a completely different language than the server where your brilliant creation finally lives?
Oh, all the time.
Like maybe you're on Windows hammering away, but your app's going to a Linux box and suddenly you're chasing down these weird gremlins you never saw coming?
Yeah, that works on my machine syndrome. It's real.
Totally. So today we're tackling that head on. We're doing a deep dive into setting up a super consistent local development environment right here on Windows.
And the key piece of tech we're looking at is WSL 2, right?
Mm-hmm.
Windows Subsystem for Linux version 2.
Exactly. That's our secret weapon,
Yeah.
along with a solid Debian foundation underneath it.
Uh-huh.
And we'll be looking at how this all comes together for a specific application called TomeStackLite Basic. You can actually see it live. It's at tomelite.web.app.
Right, the Next.js and Firebase app.
That's the one.
Now, what's interesting, I think, is this idea of needing Linux locally when you're using Firebase.
Yeah.
Because, I mean, Firebase's platform as a service, right? It handles so much of that Linux server stuff for you in production.
Right. It does a lot of the heavy lifting.
So you might wonder, why bother setting up local Linux if Firebase deals with it in the cloud anyway?
Exactly. That's sort of the core puzzle we're here to unpack today, because while Firebase does simplify deployment massively,
Uh-huh.
having that local Linux environment inside Windows, well, it gives you some really powerful advantages during the development phase.
Okay.
So our mission, if you will, is to really nail down why WSL2 is such a, well, a game changer here, and then walk through the actual steps we took, configuring it with Debian specifically for this TomeStackLite project.
Sounds like a plan.
Right.
So where do we start? Why is WSL2 so crucial, even when Firebase is in the picture?
Okay, let's get into it.
Well, if you think about the whole software lifecycle, build, test, deploy, consistency is just king.
Absolutely.
Your CI/CD pipeline, that automated system, it's almost certainly running on Linux somewhere.
Good point. Yeah.
So by using WSL2 and, say, Debian locally, you're basically using the same core command line tools.
Yeah.
Your Git commands, Node.js, NPM, the Firebase CLI.
It all matches up.
Exactly. It shrinks that really frustrating gap where something works perfectly fine on your Windows machine.
But then falls over spectacularly once it hits the pipeline or production. Yeah, been there.
We've all been there. WSL2 helps avoid that.
That makes total sense. Just
Yeah.
dodging those unexpected deployment surprises. And you mentioned consistency. I remember our notes talked about file permissions too. And path handling. How does Linux locally help there?
Yeah, that's actually a really subtle but important point. Windows and Linux file systems, they just fundamentally handle things differently.
Like how?
Well, the things like who can read or write a file? Sure. But also even just file names. Have you ever had a deployment fail because it couldn't find image.png when you uploaded image.png?
Oh, God, yes. The case sensitivity thing.
Exactly. Linux is case sensitive.
Yeah.
Image and image are totally different files. Windows usually isn't.
Mm-hmm.
So developing inside WSL2 means you're working in a real Linux file system. It mirrors production much more closely.
So you catch those silly, maddening errors way earlier, like during development, not when you're trying to push live.
Precisely. Same goes for permission issues. You're much more likely to spot them early on.
Okay, so it's like an early warning system for deployment headaches. But it's not just about preventing problems, is it? There's also the whole ecosystem of Linux tools.
Oh, absolutely. The Linux command line, it's just this incredibly rich, powerful tool set.
Yeah.
Think about scripting, text manipulation with tools like grep or sed, process management. The list just goes on.
Stuff that's maybe harder or clunkier to do natively in Windows sometimes.
Right. WSL2 gives you direct access to that entire universe without ever needing to leave Windows. It really is the best of both worlds in many ways.
And it plays nice with Windows tools too, right? Like it's not totally separate. VS Code was mentioned.
Yeah, that's a huge plus. Microsoft's done a really good job there.
Yeah.
VS Code has this brilliant WSL extension. It basically lets your Windows VS Code reach right into the Linux file system inside WSL. You open a folder that lives in Debian, but you edit it with the VS Code you know and love on Windows.
Wow, okay.
You get the full editor, the debugger, all your VS Code extensions, but it's all operating seamlessly against your Linux environment.
Yeah.
Surprisingly smooth.
That sounds pretty slick. And I saw Docker Desktop mentioned too. How does that fit in even if we're not containerizing this specific Firebase app?
Right, so WSL2 has kind of become this foundational layer for other dev tools on Windows now.
Oh, okay.
Docker Desktop can actually use WSL2 as its backend engine instead of the older Hyper-V method.
Ah, I've heard about that. Better performance, right?
Often, yeah. Better performance, uses system resources a bit more efficiently sometimes. So even if you're not using Docker for this Firebase deployment, just having WSL2 installed and configured might make your Docker experience better for other things you do use it for.
So it benefits the whole ecosystem on your machine.
Exactly. It makes the overall Windows dev experience more unified and efficient.
Okay, so the bottom line seems to be, even with a pace like Firebase taking care of servers, WSL2 gives Windows devs this really consistent, powerful, integrated local setup.
That's a great summary, yeah.
All right, let's switch gears. Let's get into the nitty-gritty. The actual steps we took to set this environment up for TomeStackLite, starting with installing Debian. Why Debian specifically? Any reason?
Well, Debian has this long-standing reputation for rock-solid stability.
Okay.
And it has a massive repository of software packages. Plus, it's the direct ancestor of Ubuntu, which is super popular.
Right, lots of people know Ubuntu.
So there's familiarity there. And Debian itself is just known for being very well tested, very stable. It's a solid choice for a base.
Makes sense. And the notes mention using PowerShell running as administrator, not going through the Microsoft Store.
Correct. You can install distros directly using WSL commands in an elevated PowerShell or command prompt.
Okay, walk us through those commands.
Sure. First, you want to make sure WSL itself is up to date. So in PowerShell as admin, you run ruxl update.
Got it. Like updating the engine first.
Exactly. Then you want to make sure WSL version 2 is the default for any new installations. So that's WSL set default version 2.
Okay, make WSL2 the standard.
Yep. And then the actual install command for Debian is just robl install wd Debian.
Just like that. Mara-D for distribution, I guess.
Precisely. Those three commands run as admin, and it pulls down and sets up Debian for you.
Nice. And what happens the very first time you launch it after that?
The first launch is kind of like setting up a new Linux machine. It'll prompt you to create your main UNIX user account.
Okay.
So you pick a username, like in our notes, we use Nicho.
Right.
And then you set a password for that user. Standard Linux setup procedure.
Cool. So Debian's installed, users created. What's next? Getting it ready for actual development.
Exactly. Now you're inside the Debian terminal. The first thing you almost always do is update the package lists and upgrade existing packages.
Standard Linux hygiene.
Yep. The command for that is sudo apt update and the sudo apt upgrade. These what?
Okay, explain that bit for folks maybe newer to linux.sudo.apt.
Sure. Sudo basically means run this command as the administrator or root user. You'll need your password.
Right.
Apt is Debian's package manager.
Yeah.
Apt update fetches the latest lists of available software from the repositories.
Yeah.
And apt upgrade actually downloads and installs the newer versions of anything you already have installed.
Oh.
The BIMI just automatically answers yes to any confirmation prompts.
Gotcha. Update lists, then upgrade packages. What came after that?
Then we installed some essential build tools and utilities, things you pretty much always need for web dev.
Like what?
We installed Git, obviously, for version control at curl, which is a tool for transferring data with URLs, often used to download things, and a package called Build Essential.
Build Essential. What's in that?
It's kind of a meta package. It pulls in compilers like GCC and other libraries that are often needed when you're building software from source, or, more commonly, when NPM needs to compile native add-ons for certain Node.js packages.
Ah, okay. So it saves you from hunting down individual compiler tools later.
Exactly. The command for all those was sudo apt install git curl build essential y.
Okay, cool. System updated, essentials installed. Next big piece must be Node.js, right?
Yep. And the notes specifically say we used NVM, the Node version manager.
Right. Why NVM instead of just like sudo apt install Node.js?
That's a really good question. Using apt can install Node, but you often get an older version, and more importantly, it makes it difficult to switch between different Node versions.
Ah, right. Projects might need specific Node versions.
Precisely. Project A needs Node 18, Project B needs Node 20. NVM lets you easily install multiple versions side by side and switch between them on a per project or per shell basis. It's much more flexible.
Okay, flexibility. Makes sense. So how did we install NVM itself?
We use the recommended method, which is usually a curl command that downloads and executes an installation script straight from the NVM GitHub repository.
Okay, run a script. Standard enough.
Yeah. After running that script, there's a crucial step. You need to make the NVM command available in your current shell session.
How do you do that?
You run source.bashrc. That tells your shell to reread its configuration file, which the NVM installer just modified.
Got it. Source.bashrc. And that makes NVM work immediately.
In that current terminal, yes. The installer also sets it up so it loads automatically every time you open a new Debian terminal.
Perfect. So NVM is installed and active. Then we needed Node version 20 specifically for TomeStackLite.
Correct. So the command was simply nvm install 20. NVM goes, fetches Node.js v20, and installs it.
Easy enough. And how do we make sure v20 was the default?
We used nvm alias default 20.
Okay, so just typing node runs v20 from then on.
Yep, unless you explicitly switch versions using NVM for that session, it sets a convenient default.
And one last node-related step, updating NPM.
Yeah, it's good practice. Node comes bundled with NPM. It's package managed, but NPM itself updates frequently. So npm install -g-npm at latest ensures you have the very latest version of NPM installed globally.
Makes sense. Keep the tools sharp. Okay, Node and NPM are ready. Next up, Firebase tools.
Right, the Firebase CLI.
Yeah.
Absolutely essential for interacting with your Firebase project from the command line, deploying, managing functions, etc.
How do we install that?
Since it's a Node package, we used npm. Specifically, npm install -g Firebase tools.
The NACHI, again, for global installation, right?
Exactly. That makes the Firebase command available anywhere within your WSL Debian environment.
Okay, CLI installed. But you can't use it right away, can you? You need to log in first.
Correct. You need to authenticate the CLI with the Google account linked to your Firebase projects.
And that's the Firebase login command.
That's the one, Firebase login. Normally, it tries to open a web browser window for you to sign in. Our notes mentioned we sometimes hit a snag there, perhaps due to how browsers work inside WSL sometimes, and had to use a fallback.
Oh, yeah, the no close flag.
Yeah. Exactly. Firebase login, no localhost. This method gives you a URL to open manually in your regular Windows browser. You sign in, get a verification code, and then paste that code back into the terminal.
Bit more manual, but gets the job done if the automatic way fails.
Precisely. A good troubleshooting tip.
So once you're logged in, authenticated,
Yeah.
How do you link your local project directory to the actual Firebase project in the cloud?
Good question. You navigate your terminal into the root directory of your project. So, Hominico projects, TomeStackLite basic in our example.
Okay. CD into the project folder.
Yep. And then you run Firebase init hosting, since TomeStackLite uses Firebase hosting.
Right. Init hosting.
Yep.
And that sets things up.
It does. It kicks off an interactive process. It asks you which Firebase project you want to associate with this directory, what you want your public directory to be, usually out or build for a Next.js app, configure it as a single-page app, etc.
And this init process creates some config files.
Correct. It generates two key files, .firebase.json, which holds the configuration for Firebase services like hosting, and .firebasic, which is a simpler file that just stores the ID of the Firebase project linked to this directory.
Got it. So firebase.json for how to deploy, .firebasic for where to deploy.
That's a great way to put it.
Okay, moving on. We've got Node, Firebase. What about Git? We installed it, but needs configuration, right?
Absolutely. Every time you make a commit, Git records who made it. So you need to tell Git your name and email address.
Right, for the commit history. How's that done in WSL?
Same as anywhere else, using git config. To set it globally for your WSL user, you run two commands.
Okay.
Git config global user.name your name, obviously using your actual name.
Right.
And git config global user.email your mail at example.com, again, using your real email.
The global makes it apply to all projects within this WSL environment.
Correct. Sets the default identity for your user inside Debian.
Okay, simple enough. Now, we touched on Docker Desktop earlier. Just to clarify, even though this app goes to Firebase, Docker is still kind of there using WSL2?
Yeah, exactly. If you have Docker Desktop installed on Windows and it's configured to use the WSL2 backend,
which is common now.
Right. Then Docker is running, leveraging WSL2. So even though we're not building a Docker image for TomeStackLite to deploy to Firebase, you could still easily spin up other Docker containers if needed for development. Maybe a database or a testing tool or some other service.
So it's available as part of the overall enhanced dev environment that WSL2 enables.
Precisely. It just sits there, ready to be used, powered by WSL2.
Cool. And finally, the piece that really seems to tie it all together, the VS Code integration.
Yeah, this is where it really shines, I think, for day-to-day workflow.
So you install the WSL extension in your Windows VS Code.
Correct. ms-vscode-remote.remote-WSL.
And then what? How do you use it?
Well, you can then directly open folders that exist inside your WSL Linux file system.
Like file open folder and browse into the WSL drive.
You can do it that way, or even easier, just open your WSL terminal, CD to your project directory, Hominico projects, TomeStackLite basic, and type code
inside the WSL terminal.
Yep, and that tells your Windows VS Code to connect to WSL and open that specific folder.
Whoa, okay. That is seamless.
It is, and you're editing the files directly in their Linux location, but with the full power of Windows VS Code. And the best part, the integrated terminal in VS Code. When you open it in this mode, it's not a Windows PowerShell or command prompt. It's a bash shell running directly inside your WSL Debian environment.
Get out of here. So you can edit code and run npm, rundeb, or Firebase deploy right there in the same window.
Exactly. Edit, save, run commands, see output, debug, all seamlessly within VS Code, connected to your WSL backend. It's incredibly efficient.
Wow, okay. That really paints a picture of a very productive setup.
It really is. So just to kind of wrap up that setup part, we went through installing Debian via PowerShell, basic configuration with apt, setting up Node.js properly using NVM.
Installing and authenticating the Firebase CLI.
Right. Configuring Git identity and understanding how Docker and especially VS Code integrate so tightly.
Yeah. It sounds like a really robust way to get that consistent environment on Windows, even when you're ultimately deploying somewhere like Firebase.
It equips you with the same core tools and a very similar Linux environment to what your code will encounter later in the CI/CD pipeline or in production itself.
Exactly. It feels like it really empowers Windows developers, giving them that first-class Linux dev experience without having to dual boot or switch machines.
Yeah, absolutely.
You get the tools you need for modern apps like TomeStackLite, you can talk to services like Firebase easily, manage your code with Git, and you're set up nicely for CI/CD.
It covers all the bases.
So for everyone listening, maybe the final thought here is, think about how understanding your underlying dev environment better, really getting it consistent with where your code will run, how that could make your development process smoother, faster, more confident.
Yeah, it's a good question to ponder.
Regardless of the specific platform you're targeting, what possibilities does this kind of seamless integration, like we saw with WSL and VS Code, unlock for your projects, for your learning? Definitely something to chew on. How much friction could you remove from your own workflow?
Exactly. Something to explore further, for sure.